Hey everybody. Today we're doing a couple of examples of confidence intervals with the t-distribution. That is, in situations when the population standard deviation is not known to us and we have to use the sample standard deviation instead. Example 1. In a typing test, an employee completed 726 words in 15 minutes for an average of 48.4 words per minute. Suppose the standard deviation in that sample is 10.4 words. Construct a level 95% confidence interval for the employee's overall average typing speed. So you should pause the video, give this one a try before seeing my solution. Since we only have a sample standard deviation S, not a population standard deviation sigma, we're going to construct this confidence interval using a t-distribution with n-1 degrees of freedom, where n is the sample size, rather than using a z-score from a standard normal distribution. The interval has this form, x bar plus or minus t star s over square root of n. X bar, the sample mean, s, and n are all just things we can plug in. The real job is to find t star. The value t star is chosen according to the confidence level c equals 0.95, using this picture. So here I've drawn two values, negative t star and positive t star. Those are the things I'm trying to find. And they're supposed to be capturing 95% of the area under the graph of t of 14 in between them. Here I'm using t of 14 because the sample size was 15. Fundamentally, this is going to be an inverse calculation in the t-distribution with 14 degrees of freedom because we're given a probability or an area and we need a value back. Unfortunately, such a calculation needs an area to the left, not an area in between. So we have to find the area to the left of t star here. So there's symmetry here. So if we have 95% in there, 5% left out, 2.5% has to be on the far left, 2.5% on the far right. So there has to be 97.5% of the area under this graph to the left of t star. And that's the value I'm going to pass to my inverse cumulative probability function. My technology of choice is R, and there the command is qt of 0.975, 14. So the area that I'm interested in, the probability to the left, and the degrees of freedom. When I execute that code, I get a critical t value of 2.1448. Now I really just am ready to plug in to this equation and compute my confidence interval. When I plug in and simplify, I get 48.4 plus or minus 5.8. So with 95% confidence, the mean typing speed is between 42.6 and 54.2 words per minute. And by that I mean that if I were to do this procedure repeatedly, going out and getting samples of size 15 over and over and over again, creating a new confidence interval each time, about 95% of the time, that interval will include the person's true average typing speed. Example 2. Using the IRIS dataset, which comes preloaded with R, create a level 95% confidence interval for the length of iris petals. So if you're working in R, you should pause the video here, otherwise I will show you some computations on the next slide that you can use to proceed, just as we did in the last example. So we need to compute x bar, s, and n from the sample data, just so we can plug into this formula. And in R, those commands are mean, SD, and length to get x bar, s, and n respectively. The main thing is to compute t star. Since we're at a confidence level of 90%, we need to find the value of t star with 95% of the area to the left. Because if we're leaving out 10%, there has to be 5% on either wing. I'm doing 90% plus 5% to get 95%. The R command here is qt of 0.95, 149, because the sample size is 150. Overall, that gives us t equals 1.655. Plugging in all of that and simplifying, I'm getting 3.76 plus or minus 0.24. In general here, when you're rounding, you should round after all your computations are done, not midstream, otherwise those rounding errors can amplify one another. So, with 90% confidence, the mean length of iris petals from this population is between 3.52 and 4.00. So I took 3.76 and subtracted 0.24, and then I added 0.24. Now, most computational tools, including R, include a function to directly compute a confidence interval with a t-distribution from the data. In R, the command is t.test, and you pass it the vector you're interested in this case iris $sepal length, and also the confidence level of 90%. If you execute that command, it gives you back a confidence interval of 3.52, 4.00, the same result we got when we did this manually.